Now we will see the second case, that is axis is inclined. Axis is inclined to either HP or VP and parallel to another plane. Okay, this is given. Other plane, right. Now we will consider one problem. A pentagonal pyramid of base side 25 mm, axis height 50 mm, lies in the horizontal plane on one of its base side. The axis of the pyramid makes an angle of 30 degrees with HP. And the side which lies in the HP is perpendicular to VP. Draw the projections. Right. Now observe the given data. The first one, A, type of solid. What is that? Pentagonal pyramid. Right. Next one. It lies in the horizontal plane on one of its edge. Okay, base edge. Okay, lies in HP on one of its base edge. Right? This is the second one. The third one, the base edge which lies in the HP is perpendicular to VP. Okay, base edge perpendicular to VP. Okay, next one, the axis of the pentagon makes 30 degrees inclination with HP. Okay, this is the other one. Next one, the geometric parameters of the solid are given. Okay, side, how much side? Side equal to 25 mm. Axis height, that is equal to 50 mm. Okay, these are the parameters. Type of solid, side and axis. These are the geometric parameters of the pyramid. And these three gives us position of the respective solid. Okay, now imagine the respective position. See, this is the pentagonal pyramid. It lies in the horizontal plane on one of its base edge. Okay, that means it is lies like this, right? And the axis makes an angle of 30 degrees. Okay, axis makes an angle of 30 degrees with the HP like this. This axis makes 30 degrees. And if up to this condition, if it is considered, the different number of positions are possible. Likewise, all these are satisfy the two conditions. But if you consider third condition, the edge which lies in the HP, that is perpendicular to the VP. Right. Okay, that is perpendicular to the VP. Now the position is this. Okay, likewise. Right. Now which position we need to draw first? If it is the final position, we cannot see its true dimensions either in the top view or front view. Is it? Yes. In the top view or in the front view, we cannot see its true dimensions. Right. But if the axis is inclined with HP, right? Now make this axis perpendicular to HP. Okay? When the axis is perpendicular to HP, it is, in this view, we can see in the top view true dimensions of the base. Okay? And we can draw that top view first. And this we need to draw like this. Right? Okay? Therefore, this position is called simple position. Once we complete the top view and front view for the simple position, whatever be the front view obtained in the simple position, the same front view will tilt like this for 30 degrees with the HP. Okay? Then this is the final position front view. After that, we can project it downwards to draw the required top view. Right? This problem, it need to be complete in two stages, simple position and first stage. Right? Now we will draw the respective front and top views. See. This is the reference line XY. Right. Now already we observe the position, and here this is the base side. It need to be perpendicular to a reference line because this is perpendicular to VP. After that, 108 degrees and 108 degrees. Right. And this length also we need to consider 25 and 25. After that, if you draw, this will give us a regular pentagon. Okay, by considering 108 degrees included angle and side equal to 25 mm, only we need to draw. We should not draw the freehand drawing. This is a regular pentagon. Right. And this is a pyramid. Whenever we consider pyramid, in the top view, all the slanted edges looks like lines which are merged at the centroid of the base. Okay. Now, by considering the angular bisector, you can locate the respective centroid. After that, draw the lines. All are visible. That is the reason we need to darken these lines. This is O. Let it be A, B, C, D, and E. Now, we need to project it upwards. A, B. This base is in the HP. Therefore, its projection obviously coincides with reference line. Base projection coincides with reference line. After that, project the axis also. Right. Now axis height equal to 50 mm. Let it be 50. Right. And axis long line dot 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 long. Okay, this is the representation. And here OC, OB, OD. Okay, these are visible edges. Therefore, these are the continuous lines. Okay, this is O dash. This is OD, OD dash. Okay, and here OC. This is okay. This is OD. This is OC. This is OB. Okay, and what about OA? OA is invisible when we see in this direction, right? OA is invisible, right? And over the invisible OA, OB is overlapped. Okay, that is the reason a continuous line we can see. Here, what about OE? OE is invisible, but on OE line, OC is overlapped, right? Now we need to tilt this for an angle of 30 degrees, right? Now consider an angle of 30 degrees with HP. This is a line with 30 degrees. This is 30 degrees. Now AB is in HP. Therefore, the front view AB here, this is here this point is A dash, B dash, this is C dash, E dash, and this is D dash. Okay, A dash, B dash in the front view need to be on the reference line. Okay, and at the same time, this axis need to be make this one, right? Here, whatever be the length you observed, okay, that length with the help of a mini drafter, okay, one scale we need to put parallel to this, okay, 30 degrees, right, and if you slide the other scale at one point, exact this distance is obtained. Let it be that distance is obtained at this point, at this position, right? Okay. After that, this length we need to draw. Okay. And this is D, and this is A1 dash, B1 dash. Okay. That one indicates first stage projection. Right? Next one, D to C. D to C. Okay. Right. Now, this one is visible, and this is A1 dash, and this is B1 dash, this is D1 dash, okay, and this is C1 dash. Now, OD is a continuous line. Here also it is a continuous line, O1 dash. Next, OC is a continuous line. Here it represents E also, E1 dash. Next one, A dash, A1 dash, and B1 dash. For that you need to draw the another side. Okay, and this is the axis. For the axis we need to draw long line, dot long line, dot long line. Right. Okay, this is the final required front view. Okay, now we need to project that front view downwards, because if you see the front view in this direction, these projection lines, it is obtained on the HP. Okay, therefore we need to project it downwards. Right. And this axis also we need to project it, and this one. Okay, base is projected, and vertex, this also we need to project it downwards. Okay, right. Now here this base we need to project horizontally, and as we observed in the planes here also, okay, this is the edge, it is like this. If it is tilted like this edge, okay, here initially, now it is moving horizontally according to the angle of tilt. Okay, that means after the tilting on this locus line only the vertex will lies. Therefore, we need to project A horizontally, B horizontally, E horizontally, C horizontally, and D we need to project like this, right? Okay. Now we need to project the vertex also, right? Now we need to identify the respective notations. See, this one, A, that means A1, B, therefore this is B1. Okay, next C, here is C, this is C. Okay, this is C1. Next E, this is E, therefore this one is E1. Next D, this one is D1, right? Okay, now we need to complete the figure by observing visible and invisible edges, right? Now for that, if you see in this direction, the outer profile, this one, this CD and DE, these are visible, and OD is visible, OC and OE are visible. Okay, therefore this is O1, OE visible, C, OC visible, right? Next, this DE visible. Next, CD visible, right? What about this OD? OD is visible, therefore we need to darken this. Okay, this is our viewing direction, OD. Next one, is it AB visible? AB is not visible, therefore we need to give the dotted line here because it is in the horizontal plane. What about AE? AE is also below the edge, therefore this is invisible. What about BC? BC also invisible, right? Next, what about OA1? Invisible, right? Therefore dotted line, and OB1 dash, that is invisible, right? See here, visible edges and invisible edges we identified exactly, and we give the respect to dashed line and continuous line. Now, how every time this imagination somewhat difficult. Okay. Now I will give a thumb rule for it. See, for any solid, the outer profile is visible in any orientation, is it not? Because without the outer profile, you cannot imagine the solid. That is the reason the outer profile must be continuous line. Therefore, this is the outer profile. It is continuous line. Right. Next one. Second point is, this is the observer position. This is the axis. Right. And the lines which are in between observer and the axis, these lines are visible. That means OD visible, OC visible, OE visible. Right? Next one. The lines which are in between reference line and the axis, these lines, okay, in between reference line and the axis, these lines are invisible. Here OA and OB, OA and OB invisible. Right? Next one, AB also in between these two, invisible, and AE and BC are invisible. Here you may ask, there's some portion here and some portion here, how you say? Actually, if you imagine the solid, it will be like this, right? At the same time, the lines which are joined at one point, two are dotted, automatically third will be dotted. Okay, that is the thumb rule we need to follow while observing or while identifying visible and invisible lines. Okay, this is the solution. This is the front view and this is the top view.